Hello and welcome. In this video, we will see how to program analog unscale block in the TI portal. So in the automation system, we uses analog signal to control VFD, to operate control wall, or to give set point to the thyristors. So to control these equipments, they don't understand engineering values, so we have to give them raw value. So in the Siemens it is 0 to 27648. So like analog scaling, we have to unscale these engineering values or to output from the PIDs to the raw value, and we can give this raw value to the field devices like VFD, like thyristor, or to control valve. Now let us see how to do that. So in the last video we have saw scaling means nothing but the equation of straight line. So here also the same formula we will be using to create unscale block. So this formula is y is equal to mx plus c. So y is your output, m is the slope, x is the input, and c is the point our where our line intercept to the y axis. So now let us derive this formula and let us create analog and scale block. So now here we will take one CPU. So like analog scaling block, this analog unscale block, it is using same formula. So here first we will write the formula. So here our output, that is raw value. So our output is equal to our raw max minus raw mean divided by input max. So this input max is the maximum set point which is coming from the PID or from the HMI or from the PLC logic. Input max minus input minimum so here multiply input minus input minimum and plus here we have to mention the c, y is equal to mx plus c. So this is m, this is x plus c. C is your raw minimum. So now let us define the inputs and outputs to the block. So here input is the input which is coming from the PID, or which is coming from the HMI, or which is coming from the particular logic. So here we will use input maximum. The data type, it will be real. Input minimum, raw maximum. So here raw maximum is 27648. Raw minimum, and the default value is 0.0. So output is unscale. So here data type we want integer. Okay, so here we require one variable uns unscale real. So we will do the calculation this, and we will put the value of this calculation in the unscaled real, and at the last we will convert that unscaled real to the integer. So here we will start building this particular formula. Raw max minus raw mean divided by input max minus input mean. So here we will be copying everything in the unscaled real. Okay, so this is the m. So we will write the x. X is your input minus input minimum and at the last we will raw minimum. That's it. So now your unscaled value, it is ready. Now what we will do again, for safety operation, by considering safeties or alarms, we will generate some safety thing. So here if input is less than input max, and if input is greater than input minimum, then error. Okay, so we have not defined error output, so here we will also define error data type bool. So error is equal to false, else error is true. So when the input, so this input, it will be coming from the PID or from the HMI. So if this input is less than input max, and if this input is greater than input mean, then error is equal to false, and if this condition will become a false, then error will be true. So if input is less than input minimum, then unscale real is equal to raw minimum. So whenever the input, if that input is less than the input minimum, now let's say if our input minimum is 0, and let's say by in case by calculation error, by doing some wrong entry, if that input is less than 0, then raw minimum it will be moved to unscale real. So if any user by mistakenly or by accidentally, if he enters less than 0 value, then our raw minimum value will be carried to the unscale. So this will be safety for the equipments. Else if input is greater than input max, then unscale real. So when user by mistakenly, if he enters greater than, let's say, 100%, then on the field it will be given 100 only and not beyond the 100. And if the input is in between input mean and input max, then our this thing we have to put here in if close. So this is the only logic for the analog. unscale block. So now what we will do, we will close and we will call this block and we will test it. So so we will add one db. So in the db we will add some input minimum, input maximum, input, so data type it must be real, and here unscale value, and here so this conversion I think we have not done in the our block. So here we have to convert real to integer. So this real thing, so we will copy and we will paste it here. Now it is done. Okay, now here we will input max, input mean. So raw max it is all, it is 27648 and 0, it is by default. And here on scale we will give our value. So now everything is ready. What we will do, we will start simulating it and we will test it. So PLC sim, click on load, connect, no. And click on load. So now here let's consider the maximum value for the VFD from the logic or from the PID or from the HMI. It is 0. Now let us check. We will give 50%. So the output is 13824, and if we give 100%, it should be 27648. But here error is getting true. Now we will check. Here we can use greater than or equal to. Now it will be okay. So now if the input is 50%, 13825, and if it is 0, error is false, and output is unscaled, output is 0. So here again we will force 25%, 6912, again 75%, 20736, and 100%, 27648. And now let's see, we will force 200%. Error is true, but output is 27648. So this will ensure that our field devices, it will be safe. And once we enter in between 0 to 100, error should be false. Error is false now. So in this way we can use analog unscale block by using SCL language. If you like the video, please like, share and subscribe. Thank you.